That leads us into the second part of the presentation, and the final aspect I'll address concerns the growing customer demand to provide onboard interfaces for custom FPGA designs. There's a nascent need in ATCA blade subassembly integration to further integrate and facilitate the adjunction of custom functions where company or application specific IP needs to be retained from previous generation architectures, or where newly developed FPGA-based IP in combination with a server class processing function on a commercial off-the-shelf ATCA blade makes an explosive mixture for gaining a competitive edge. And some of the examples of functions we typically get involved in at Advantech are shown here. Not all demands right now are telco specific apps. That proves that ATCA is definitely becoming an increasingly mature and wider reaching architecture for the design of high performance computing equipment. But above all, designers of non-telco products can start to reap the economical benefits created by the telco market and select from a wider choice of standard blades for the core processing on which to drop their own IP and I/O. When you want to integrate your own hardware IP with ATCA, there are a lot of options to choose from. And of course, if you have the time and resources to invest to develop it all on your own, then the necessary specs and testing suites are there for you to do just that. But many of us have been in this business long enough to know that upfront NRE investment and the recurring costs which revisions and refresh bring need to be taken into account for the famous make versus buy equation. So to balance out all the make options on the left side, I've listed all the benefits of an intellectual property sharing approach on the right side. This approach is proving itself quite successful in accelerating customer design cycles for rapid prototyping, and it's speeding up the whole development process. So by sharing things today with customers like schematics, layouts, firmware, and even test rigs, the development cycles are compressed, complexity is removed, and time to market is dramatically improved. Well, I guess the next question is the placement of custom IP. If we're looking for the simplest approach and one which doesn't involve a full advanced mezzanine card design or loss of an advanced mezzanine card slot on the front board, then the rear transition module in ATCA is a good fit, and it's also close to application I/O. The two principal items which Advantech has adopted with customers to achieve successful rear transmission module designs with custom I/O are a well-defined transition module interface and a comprehensive RTM design. Advantech has implemented a common mechanical and electrical interface for its RTMs, which allows the front blade and rear module to interface and communicate in a defined manner. Then by clearly defining the through management process and ensuring electrical compatibility, the same rear transition module can be used on successive iterations of the front blade without the need to redesign. The design kit mentioned here provides an easy to implement toolbox that we can provide to customers for fast and smoother design. The recipe for interfacing to an application's secret source depends a lot on the state of your kitchen and the utensils you have available. Well, here in the Advantech kitchen, we bring out a wide choice of connectivity to the front panel over the Zone 3 connector, allowing high-speed interfaces to be used like PCI Express, ZOE, SGMII, etc. And we simplify the whole through management process with the necessary logic to speed the customer's hardware development process. The important point here is we provide the chef or designer with an efficient kitchen or design lab, along with everything needed to make his secret sauce without any encumber. This next slide here is really just for later reference. It provides an overview of the support signals for power management and link usage. This slide introduces another approach to integrating custom IP, this time by means of what we call a fabric mezzanine module. This approach takes the rear transition module customization concept one step further by modularizing the custom IP rather than putting it down on the PCB. Or as an analogy, by canning the secret sauce for reuse or adaptability to another dish. Now, in effect, it defines the high-speed interfaces with the mainboard along with the through management implementation. In addition, it can support a Zone 2 connector interface to enable custom fabric connectivity like ZOE, KR4 or SRIO. Any signal integrity issues are resolved by the use of a redriver down on the mainboard between the Zone 2 connector and the fabric mezzanine. Another benefit of the fabric mezzanine is it has been conceived to support front I/O, and so can be used for physical connection to the front panel of the front ATCA board or the rear transition module panel, or even on other architectures like servers and network appliances. This slide is once again just for your reference in the slide pack. The fabric mezzanines are extremely compact, just 7 by 7.5 centimeters, and use FMC compliant connectors for high-speed differential I/O over 10 gigabits per second. The I/O area provides sufficient overhang for connector support on front panels or rear transition modules. There's enough space to fit 40mm BGA ASICs and FPGAs and associated components within a typical thermal budget of up to 20 watts. The fabric mezzanine concept modularizes integration to facilitate the work of system integrators who need to provide much more modularity in port and I/O configurations in order to scale with different market and application needs. So as well as providing an innovative and effective method for FPGA co-processing on or custom fabric support, the concept can be taken further to provide broader PHY choice, additional storage options, complement quick assist implementations on Intel-based designs, or add further co-processor options. Now, the first mezzanines Advantech are going to deploy in 2010 are Intel's Niantic, that's the 82599 10 gig Mac shown here, and the ATI GPU fabric mezzanine. Others will be released later in the year or on customer request. Now, the first blade to support fabric mezzanines will be the MIG 5322. That's a dual next generation Intel Xeon blade. And so to summarize, well, integration with ATCA takes place at many levels, and there are opportunities to add clearly differentiating value at each one. Thanks to well-defined standards and robust test suites, interoperability is widespread and well controlled. Integration needs a lot of expertise, so even when you do it yourself, close collaboration with your suppliers is key. And finally, in a make versus buy world, cooperation and IP sharing brings lots of benefits for make and buy. Well, if you'd like more information on Advantech's rear transition module interface or fabric mezzanines, feel free to drop an email to Peter Marek or myself at the email addresses below. And please visit our website at www.advantech.com/NC. That'll take you straight to the networking and communications website where you can get direct access to complimentary information. Thanks for listening and have a great day.